So there's 4 services in the program that I want to tell you about. The Condo and Institutional Cluster, support for cloud computing, support for virtual workstations, and then a consulting program to tie those together. So the Condo and Institutional Cluster, which launched this week, is the first of them. It's up and running thanks to tremendous effort from our partner team from the Lawrence Berkeley Lab High Performance Computing Group. And we really appreciate it. We would definitely not be here without you guys, and kudos to you. It's very exciting that we've actually got the astrophysics team in and compiling software and playing around with it at this point. We're doing benchmarking on this, and Gary said that the levels of scaling on this are among the best they've ever seen. So we're really pleased with the hardware we've got in place and with how these guys have managed to put it together. Now, some of you may be asking, what is a condo model? I mean, you've heard some people refer to this. Basically, we have institutional infrastructure within which we can add additional computing. So individual PIs and research groups can use funds, typically grant funds, to buy hardware. They contribute that into a shared resource. They benefit from the campus subsidizing that infrastructure and the administrative costs there. The campus benefits by being able to offer the unused capacity on that hardware to the rest of campus. So we're effectively taking research dollars and leveraging them further across campus. Now, we talk about it as a condo and institutional cluster. There is this institutional half, and part of what's important about that is to provide the infrastructure and incentive to condo contributors. But as well, we want to guarantee a certain base level of access to all faculty on campus. So we're talking about a birthright program that ensures a certain number of compute hours are available to faculty and PIs across campus, and that there's another pool available for students studying computational methods in various disciplines. This is a really important aspect of it, so that it's not just serving some of the folks who have considerable resources, but is providing broader access across the campus. So it ensures that we can be more competitive in faculty recruitment and retention. It ensures that we can provide access to students who are studying some of these programs. Now, not everybody needs the specialized hardware that we associate with traditional high-performance computing. There's a lot of people on campus today that are using Amazon Web Services. Some of them are looking at Azure and some of the other public resources. These public cloud services are really important for what are often called embarrassingly parallel algorithms because of the way they allow folks to scale. Now, at an individual level, it may look like the cloud makes more sense than buying a lot of hardware if they've got relatively modest needs. But if we aggregate demand across the campus, we may find that it makes more sense to actually aggregate some of that demand and have some support here in a private cloud form. We're not sure exactly what we're doing yet. We're very excited to be working closely with EECS and folks from the College of Engineering to look at this. They're also looking at what they need to do to provision resources to teach cloud computing classes. So they've got some of the same concerns that the campus more broadly has. Working with them in a collaboration, we expect to be able to figure out what's the right blend of public cloud facilitation, like we have at Amazon and Azure, private cloud services that we might offer through the data center, or hybrids thereof. We might do a virtual private cloud. So we're hedging our bets on that now. We're in the early stages of figuring out what the alternatives are. We're starting to look at other universities that are doing this, and again, following that same process of understanding what works and what we should avoid. Now, as I said, there's folks that have more modest needs, although what's often a pain point there, coming back to this issue of software licensing and being able to get access to the software with a powerful enough environment. There are lab workstations around now in many of the instructional and labs in places like the D-Lab that are doing a great job supporting researchers right now. They've also got the consultants to support researchers in using this software. But they're constrained in terms of the hours that they can offer it, and people have to come into the lab physically to be able to use this. So we hope to be able to supplement this, working with these folks to actually provide 24/7 access to a lot of these stacks. So this is one of these things, again, in partnership with the D-Lab, ETS that runs instructional labs, the library, and some of our IST partners as well, looking at what the range of solutions are here. And this one may be more piecemeal in terms of looking at individual solutions, given that we do have some support now. We're, again, looking at other universities as patterns and then talking to folks on campus about what's the best model. Now, all of these services are just technology, and without a consulting component, we can't just pitch it over the fence and expect faculty to use this stuff. And so we recognized early on that the consulting aspect of it was really important. You heard that several of the other speakers talk about this. BRC is making a significant investment in the consulting team within BRC, and in addition, we're interested in a model of having domain consultants part-time or in a fellows model working with us so that we can benefit from some of the expertise in statistics, in computational biology, and some of the things going on in places like the AMP lab, where we've got all this expertise. Right now, those people are busy and heads down in their sort of vertical areas on campus. Bringing them together, we can benefit from one another's experience more, we can share that experience around, and we can ensure that there's more cross-teaching and learning there. There's also a broader community out there outside of whatever we can provide that will continue to serve faculty. And that community context is really important in terms of being a broader partnership for our consulting group. We're not going to be able to scale to deal with everybody across every single domain. And so having that community out there is a really important aspect of it. And we work very hard to build some of these partnerships to ensure that that community works. So this slide just illustrates the idea behind all of these different domains, from the humanities to physical sciences, social sciences, and life sciences, issuing requests in, working with the community and our consulting group, we can figure out what's the most appropriate service for them. Especially as things change over time, understanding what technology is best fitted to a given research need is a really important challenge. And this is one of the areas that we think it's going to be important to have the community and the BRC consulting involved. Another thing that's really important about the model is recognizing the importance of what we call mobility of compute. And what we mean by that is that over time on an individual project and over time as technology evolves, people may be moving from one service to another. It may be appropriate for certain things to go from high-performance computing to the cloud over time. As projects scale, they may start on virtual workstations and then scale up to take advantage of cloud-scale resources as they handle more data. The important thing is we want to make sure that it's easy to do that we don't end up with siloed services where people who know how to do one kind of thing have a hard time moving to others, especially as the market and technology evolves. At the same time, there's another kind of mobility. I mean, people will move from personal environments into BRC computing, but they'll also be doing things like on-ramping from small-scale resources that we have. They're relatively small scale compared to national infrastructure, and being able to easily move from our condo and institutional cluster out to national infrastructure and back, being able to move from whatever we do in cloud out to public cloud and back. That mobility is really important in terms of making sure that the research is effective and repeatable. So I mentioned partnership, and I'll mention it again because it is so important. We would not be where we are today without our partners from the lab High Performance Computing Services group. We would also not have anywhere near the understanding we need without the D-Lab and many of the folks there who generously spent their time working with us. We're really excited about the chance to work closely with the College of Engineering to understand what we need to do in cloud. And there's a host of other partners. We've been very lucky to have a great response from the network and storage teams in IST who really engaged with us as we brought up the condo. We were able to use more of those services than we expected in really creative ways. And there's, you're seeing lots and lots of partners come up here. There's so many, and there's many that I couldn't list here. But we think this is a really important aspect of it. BRC is not going to subsume research computing on campus by any means. We're trying to fill some gaps and provide some key services, but it will work only as we develop the partnerships and build that community across campus.